Hi, my name is Leo,
Hi, my name is Zhiheng.
and today we're going over our modifications to our ALU and decoder for Lab 3. So for Lab 3, we use a temperature sensor, and our decoder code is here. And so the first part I'll be going over is the 3 wires that we made within our decoder in order to measure for the Celsius, Fahrenheit, and Kelvin temperatures. So what we did is we took the Celsius input from the temperature sensor, put it through a temp converter here, and then we took those values and calculated the tens, ones, and the hundreds place for the Fahrenheit and Kelvin in order to find out what we needed to display on each 7-segment display. Further down a little bit, we have the select feature within our code where we use 2 switches to determine whether we wanted to display Fahrenheit, Celsius, or Kelvin on our FPGA.
So the next part is what I did. So we added a detect mechanism for our code. So if the temperature sensor get temperature above like 80 Fahrenheit, the first 4 bit of our 7-segment will display high to alert people temperature is too high. But since like human can't heat the temperature sensor that much, we just set a threshold kind of low. But just to display, we have this mechanism. And next one is each of the anode. So basically, if anode equal to the first bit, the first right bit of the anode displays a unit of our temperature. It's either Fahrenheit, Celsius, or Kelvin. And the second bit, third bit, fourth bit will display the number of our temperature. And then it's like the next 5 to 8 bit will show 5 to 7 bit. No, it's 8 bit actually. 5 to 8 bit will show the high. It's like all empty if the temperature is not higher than a specific value. That's all I did. Thank you.
So next here we have our demo on the FPGA board. So first we have 77 Fahrenheit, 25 degrees Celsius, and 298 Kelvin. And so now we are calculating the conversion from Celsius to Fahrenheit, and by doing that we multiply by 9 divided by 5 and then add 32, which in this case 25 goes to 77, which is displayed there. And then in order to convert it to Kelvin, we add 273, which equals 298, and that is displayed.
So here we're trying to heat up the temperature sensor to make sure it above the threshold, which is 80 Fahrenheit. But it's kind of hard to increase temperature of the temperature sensor. But once it's above the 80, there's a high display in the first 4 bit of the 7-segment, and it says high. And also the conversion from the temperature, like Celsius to Fahrenheit or Celsius to Kelvin, is all correct. So here for our successful part, we actually add our select bit to control the unit of our temperature information. And also we add a detect mechanism to make sure if the temperature is higher than a specific threshold, there's an alarm display in the 7-segment. That's actually, I think, what we did very creative. And next part is our failure.
And so for our failure or challenging parts of our code, occurred in this section of the code, as we took inspiration for our code through FPGA's dude's code on temperature sensor. And so in doing so, we also added a function of measuring Kelvin from the Celsius. However, he didn't originally have Kelvin, and so because we had Kelvin, we needed to add another measurement to find out the hundreds place. And so what we found out is after having a hundreds place, we needed to add this new line in the tens place in order to make sure that we were able to accurately measure tens correctly. Because if we were to measure a temperature of, let's say, 270, dividing it by 10 would output a number of 27, whereas we just wanted the 7.